Episode 171 of CppCast with guest Hana Dusíková, recorded October 16th, 2018. Today's sponsor of CppCast is the PVS Studio team. PVS Studio can be considered both as a tool for finding errors and typos and a static application security testing tool. The tool supports the analysis of C, C++, and C# code. In this episode, we discuss auto to stick. Then we talk to Hana Dusíková. Hana talks to us about her compile time regular expressions library and much more. Welcome to episode 171 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm doing all right, Rob. How are you doing?
Doing okay. You got a busy few weeks up ahead for you, right?
Yeah, a little bit of overseas training coming up again and some U.S. training as well.
Okay, so yeah, the schedule might be a little erratic. We might, record 2 episodes one week and not one the following, but we should continue to have episodes out for the next few weeks. Yeah.
Yeah, I don't think our listeners will notice a difference at the moment.
Right. Okay. At the top of every episode, I like to read a piece of feedback. This week, I got an email from Tony. He wrote in, "Hi, chaps. Thanks for all your continuing work on CppCast. I enjoy it every week, and I think it's an important part of the C++ world. Please may I cast a vote for trying to get standard library maintainers on as guests or repeat guests. I feel people like Marshall Clow and STL will always have plenty of valuable material to discuss on repeat visits. And I'd be interested to hear from Jonathan Wakely, who, I don't think we've had him on yet. Right, Jason?
I don't think so. And Eric Fizier, I don't think we've had on yet.
Yeah, so
it's
definitely
also standard library, yeah.
A couple of names that we could try to reach out to. And, Marshall and STL were both a lot of fun to talk to, so maybe we could try to get them on again sometime, too.
Mm-hmm.
Yeah. Well, we'd love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Hana Dusíková. Hana is working as a senior researcher in Avast Software. Her responsibility is exploring new ideas and optimizing existing ones. She also propagates modern C++ techniques and libraries in internal tech talks and gives talks at local C++ meetups. She studied computer science at Mendel University and subsequently taught several courses there, including data structures, computability and complexity, and formal languages and automata. Hana, welcome to the show.
Hello.
Hey, it's great for you to join us. I'm curious, and this is something you mentioned to us in an email, so I thought I'd bring it up now, is how did you get started programming?
Yeah, I started programming when I was like 8 years old. My dad has a computer. It was Z80 machine, ZX Spectrum.
Okay.
And there was a lot of games, and after I play a lot of them, I think I left just programming.
So you just started coding away?
Dad had a lot of computer newspapers, and there was at the end of every one, there was a program you can rewrite in BASIC.
Uh-huh.
So I rewrite it, and then I play with it. What happened if I changed this and this? And I started programming.
So on a Z80, you said that's a lot of our listeners. That's their first CPU, and it was a favorite for them.
Yeah, it's favorite. My favorite too.
So at the time, was it all BASIC, or did you get into it and learn machine code and stuff too?
Only BASIC. It was dark magic for me then.
Yeah, I totally agree. It was 30 years after I got rid of my Commodore 64 before I actually learned any 6502 machine code.
Okay, well, Hannah, we got a couple news articles to discuss. Feel free to comment on any of these, and then I want to talk more about your talk at CppCon, okay? Mm-hmm. Okay, so the first one is a call for proposals from ACCU, the 2019 conference, and we've talked a few times about ACCU before. It's not an explicitly C++ conference, but they tend to have a lot of C++ content, right, Jason?
Yes, that is my understanding. I've never been there myself.
Are you thinking about submitting?
I am not this year. I think I'm meeting my conference quota with 3 for the year.
Okay, so you're already planning which 3 you're going to go to next year?
Well, I mean, next year kind of starts with C++ on C.
Right.
So, yeah.
Okay.
What about you, Hannah?
I'm going to C++ on C, so I'm looking forward to it.
Have you ever been to ACCU or thinking of going?
Sorry?
Have you ever been to the ACCU conference, or are you thinking of going?
I never been. I was only on 2 conferences, and both are CppCon.
Okay.
Well, this next one is from the Fluent C++ blog. Obviously, we've talked about a couple of these articles before and had Jonathan Boker on before. This one is auto to stick and changing your style. And Jason, you want to introduce this one? I thought it was a pretty good article, especially with some of the talks we've had recently with people saying, talking about overusing auto.
Yeah, it's based on what Herb Sutter's CppCon talk from a fair number of years ago or something, where he's basically saying auto should always be on the left. It's truly is the almost always auto is really what it is the argument for this. And I just have a hard time using it all the time personally, but he makes a pretty strong argument. Actually, I had Herb review his article for why this is a good idea and for, fixing the type of a thing. I don't know.
Yeah, I mean, he definitely points out a lot of good reasons that, why you would want to use auto. And kind of the main one being so you don't leave something uninitialized by accident.
Right.
Yeah.
That's why you should always const.
That too.
Do you use this always auto style, Hannah?
Not every time. I'm still used to type and variable name, but especially in my CPP library I present on CppCon, I use auto on the left side because it makes sense for functional programming, like you have input and output.
Right. Well, and I would imagine with a lot of what you're doing, you almost don't have a choice because a lot of times you don't even know the type of the thing, right?
Yeah.
Okay. This next one is it's a collection of videos from New Tools Cauldron, which is a recent conference, I guess, Jason?
Yeah, I had no idea that this conference existed, but they apparently get together every year and, talk about like GCC kind of things.
Yeah, that's interesting. It must be a shorter conference. It looks like there's 34 videos. That might just be 1 or 2 days worth of content.
Yeah, and several of them are lightning talks.
Oh, okay. So probably just a 1-day thing. Yeah, I'm kind of surprised by the number of conferences that are out there on what seem to be like niche topics to me. Like I think right now there's actually a GitHub conference going on. And obviously, Git's a huge tool. Lots of us use it every day. But I can't imagine going to an entire 2-day conference revolving around Git. Unless maybe they're talking about just other kind of programming in general topics.
Well, it's GitHub specifically.
Sure. It's GitHub.
Well, I mean, one of the conferences that's getting ready to happen here, since I'm on Patreon, and I don't know, maybe you saw this email as well, Rob, is PatreCon.
Really?
Yes. So everyone has a conference.
Everyone has a conference. Okay, that's interesting.
Did you look at any of these videos, Hannah, by any chance?
No, not yet.
Okay. I was just wondering if any of them stood out to you. There is one on here that was a lightning talk that I will draw attention to, if I can find it again.
Okay.
Where did it go? It disappeared.
What was the lightning talk on?
Yeah, it's on automatically tuning your compiler flags for performance.
Oh.
So it's like running your here we go. It's automatic tuning of compiler options using iRace. And basically, it's like a tool that just goes through and like iterates through all the different possible combinations of compiler flags until you can get the fastest possible binary output. And I think they said in their experiments, they're getting about a 40% performance improvement over just using -03.
Oh, wow. That's pretty cool.
Yeah, I had no idea how long it takes for it to actually run that, but I know that there are listeners to this podcast who would care, that they would invest the time of letting this tool run for a few days so they know what flags to use in the next build of their high-performance thing.
One thing I'm curious about is how do they, measure that your code is running faster exactly?
I think it's raw timing, but I could be wrong.
Okay. Interesting. And then the last thing we have is a post from a Visual Studio blog about upcoming updates to both Visual Studio 2017 and Visual Studio for Mac. Obviously, it looks like they're starting to talk more about the upcoming Visual Studio 2019, although I don't think we've still gotten a date on when we could expect that. But version 15.9 of Visual Studio 2017 should be coming out pretty soon, it sounds like.
Yeah, and I think the main news here is 15.9, they said, is the service pack. Once 15.9 ships, they're no longer supporting the old versions of Visual Studio 2017.
Right, that makes sense. But I mean, they've put out so many updates over the past 2 years. It seems like we've gotten a lot of new features via updates. Yeah.
Well, one of the main comments on here says, I just want to return to stability because it's been so many, so many changes between each sub-release or whatever. And I don't know if that's fair or not. I personally have not seen instability, but I do I verify that Visual Studio is doing what I want it to do. I don't do my main development in Visual Studio.
Right. Yeah, I haven't noticed any stability either, but and I update usually as soon as they come out. I don't usually dip into the preview releases, though. No,
I don't do that.
Yeah. And Visual Studio for Mac, I'm not using that one either. I believe that's not a C++ IDE. That's just for C# and Xamarin and stuff.
I have no idea. I tried to not use my Mac. In fact, I need to get rid of it if anyone wants it.
And are you a Visual Studio user or you live on Linux?
I'm working on Mac and I'm using TextMate and Terminal. Nothing else.
Okay. Yeah. So you don't even use, why can I never remember the name of Apple's IDE?
Xcode.
Yes, so you don't use Xcode?
No.
Yeah, I could never bring myself to use it. But, I mean, I use Vim everywhere, and that's something I can rely on being everywhere, so there's no reason to use Xcode, I don't think, when I only use that once every few months or whatever.
Every time I open Xcode, I'm shocked by complexity and I want to return to my TextMate.
I understand that.
Okay, well, Hana, so this year, CppCon, just a few weeks ago, you gave a talk on your compile time regular expressions library. And I think, Jason, you were in the talk. I did not make it, but I did get to watch the video afterwards. But even while still at the conference, I heard a lot of people talking about your talk, how it was really interesting and impressive what you managed to achieve. Can you just start off by telling us a little bit about what you're trying to solve with your regular expressions library?
I wanted to try to solve problem of expensive construction of regular expression. It's too expensive, I think, and your program shouldn't do it every time it's run. It should be done as a code during compilation. At least for me, because my regular expressions are stable static for whole program.
That's a good point. I don't think I've ever personally worked on a project that had dynamically created regular expressions. You either knew what you were parsing or you didn't.
I think 90% of usage of regular expression are static. If you are not doing text editor or database, you don't need dynamic regular expressions.
Right. Oh yeah, that's a good point. I have used dynamic regular expressions in the context of SQL queries before, but I think that's the only time I've ever done that.
Maybe. I don't know.
Yeah.
So how does your library exactly parse these regular expression patterns at compile time in order to avoid doing it at runtime?
I actually needed to build LL1 parser with a recursive distance parser, and I parse it to intermediate data structure in form of type list, and then I transform type list into something similar which can be used in matcher, which is like type list of type list of type list of type list.
Okay, so can you explain for us, because I know this is going to sound terrible. I do have a scripting language, but I don't know anything about parsers. What does LL1 parser mean?
LL1 parser is context-free grammar parser, which needs some form of stack, and it's deterministic. So by looking on next symbol, in this case one char, it decides where it should go. So if you correctly design your grammar, it can be ON algorithm.
Of the actual parsing of it is ON?
Yeah.
Okay.
Yeah.
So do all regular expressions fall into this LL1 parsability?
Regular expression patterns are in LL1, can be LL1 grammar, but regular expression itself are just regular languages.
Oh.
There are two parsers in my code. There is one parser which translates the pattern into some representation, and there is a matching of regular expression. Regular expression, strength of the regular expression is only regular languages. There are classes of languages, and each type is more powerful than previous one. The least powerful language is regular language. Then there are context-free languages, which are most programming languages. Then there are Turing machines, which are programs by itself. But syntax of almost every programming language is context-free grammar, even C++ with some hacks.
Okay, so you can parse the regular expression at compile time, but you cannot execute it at compile time. Is that correct?
No, it's not correct.
Okay.
I can parse it, and I can evaluate it and match it against input.
Oh, okay.
But actually, I'm using one parser to create another parser to parse content of subject.
Okay. So you use the parser of the regular expressions to create a new parser that then can do the matching or whatever.
Yeah.
Okay.
And the parser is actually itself, it's just a type I created during compile time, and so you can work with it as with type. So you can join them together to regular expressions, or do subtraction, and anything else.
Okay, if I remember correctly from your presentation, it looked like this type that you generate at compile time is it could almost be used as a way to visualize the regular expression, because the type had everything right there in it for what the regular expression was doing.
Yeah, the type is actually the regular expression in just a different form.
Okay.
And, I was able to design matcher which take this form and do the matching.
Wow.
Very cool. How does the library compare with some of the other regex libraries out there, including the standard regex library?
I'm on par with PCR library, which is similar in most cases. In some cases I'm better. In some cases PCR is better. But for other libraries, like POSIX regular expression in egrep, I'm usually 10 times, maybe even quicker. I tried benchmark RE2 regular expressions from Google, and I'm like 10% quicker than them. I tried regular expression to C compiler, which generate actually C code with a state machine, and in most cases I am 10-20% quicker.
It's pretty impressive.
That's amazing, yeah.
Thank you.
And then the standard library ones?
Yeah, standard library ones is special case. I don't know why, but they are so slow. When I benchmarked them, I actually killed them a few times because I was thinking that they stuck. Something I can match in like 3-5 seconds, and I mean 1 gigabyte files. Regular expression in standard library took 50 minutes, for example.
Wow.
So you're orders of magnitude faster than them.
Yeah. In this case, I'm talking about libc++ regular expression. So the Regex implementation is much better.
Okay.
But still, it's kind of slow, like minute versus 5 seconds.
Now, I know you're not involved in the standard library implementations, or at least I don't think you are. But do you have any idea why they're not just using PCRE or one of the already proven ones in the backend when they can?
I don't know. I can only imagine maybe it's license problems. I'm not sure.
Okay.
I believe in your talk, you talked about a couple C++20 features that your library is dependent on. What platforms is it currently supported on?
Currently, you can compile it on Clang, I think, version 4 and newer, and GCC 7.2 and newer. I'm using a feature called string template literals, which was designed as implementation for paper N3596. I'm not sure. Okay. And it was designed to create string literals which give you charpack instead of constchar and slice-t. So you can use charpack as a string during compile time, but it wasn't approved by committee. And based on this design and later, then Jeff Snyder's came with much better design, which allows you to use almost any type as a template parameter.
Okay. So this is the C++20 feature that is just, Yeah,
it's called class non-type template parameters.
Right. Okay, I did not realize that. Okay.
And in my library, you can use extension, which is currently in GCC and Clang, which is in C++17 extension, GNU extension. Or if your compiler is able to use class non-type template parameters, then by using feature test macro, my library will support new form of syntax automatically.
Okay, so right now, can it work in Visual Studio at all?
Not yet.
Okay.
I asked Stephen Lafayette if they will be implementing this feature. They will be implementing it soon in Q1 next year.
Oh, okay.
And then it should work on C++ in Visual Studio.
Maybe without, making too big of a guess here, if he said Q1 of next year, they might be referring to the first release of Visual Studio 2019, hopefully.
It could be, yeah.
Hopefully. But this feature is depending on operator UFO.
Oh, what's that?
UFO operator.
Oh, okay. Right. The three-way comparison.
Yeah.
So are you aware of anyone using your library yet in production code?
I'm aware only about me, but there was a lot of people who asked me a lot of questions, so maybe someone is using it. It's new, it's just 2 weeks in public, so maybe. I hope so.
So it is actually being used in your projects at work?
Yeah.
Oh, that's cool.
Yeah. So you actually did a lightning talk about this library last year at CppCon, and it sounded like you maybe have gone through a couple different iterations of this library. Is that right?
Yeah, this is like 6th or 7th iteration. I'm not sure. I played with idea like last 4 or 5 years, and I tried a lot of different approaches. Some of them work, some of them don't.
Wow.
So when you come up with a new iteration of the library, you kind of like starting from scratch with just the same basic idea of, I want to make, these regular expressions, parsed at compile time, but each one is a unique library.
That's original idea, but implementation was completely different. In this time, I used function overloading the resolution as a major engine of my library, and it works, and it's rather elegant code I can explain on one slide.
Yeah, when I saw how you were using function overload resolution, I think that was the piece that I was missing when I last tried to write a parser that could run at compile time. But that leads us to a question Odin Holmes wanted us specifically to ask. How did you come up with your unique style of metaprogramming using these techniques?
I usually read papers in future C++, and I play with them if it's possible and try to use them in different scenarios and how they work together. And then sometimes I found something, maybe I learned something which is already known, I don't know. And then I came with the idea, and then I try to implement it, and if it works, it works. Everyone say that template metaprogramming is Turing complete. So by theory, you should be able to do whatever you want.
Right.
So I implement parser.
So that sounds like extremely valuable experience. There's not very many people who actually try the new features as they're being developed to see how they interact with each other. Have you ever written up your experiences on this and submitted it just as I forget, there's not a proposal to the committee, but just like an info paper to the committee on how useful these features are?
I didn't.
Okay.
I don't like writing.
Well, on the topic of that, though, I did notice that you do have a paper for San Diego. Is that correct?
Yeah, there is one paper as first author, and I think 2 others with me as second author. Maybe only one, I'm not sure.
Can you tell us about the paper?
The paper is a new attribute to C++20, which should allow you to introduce new diagnostic, user-defined diagnostic. If your function sphinai or requires or just attributes do not match, it should give you the diagnostics. For example, in my case, in my library, I was thinking if I should use sphinai check, if I can build the regular expression or use static assert. Static assert can give you custom diagnostic, but sphinai check is more friendly to other sphinai programming. And you cannot have both. And this attribute should change it.
Okay.
So in case you ever wanted to have custom error message, if your overload cannot be used because some constraint, for example, your t is not numeric, this constraint should help you.
Oh, okay.
Maybe some will argument that you don't need it because concept should solve it. But it's not actually true. Concept can give you nicer error messages, but if you have very complex concept, it can give you very bad error messaging. For example, in my case, I can introduce a concept which check if regular expression is correct and if it doesn't contain any captures. Because if there is no captures in a concept, I can use different engine to match it, which is much quicker than backtracking.
Oh, interesting. Okay. I also noticed that your name is on a paper with Bryce Edelstein-Laubach on implicit constexpr.
Yeah, that's true.
That one, that looks interesting to me.
Our original thing was there is a lot of work that everything will be constexpr in few years. We can agree on that.
Yes.
So why just cut it and make constexpr everything now, just by saying compiler should be able to evaluate it. And that's everything done. You don't need any work. From my perspective, I'm not expert.
Right.
But ideally, you should be able to invoke some code generated by compiler, even in some different library, and place it as a parameter for template, for example.
Right.
It should make a language much easier and simpler to use.
I guess there's no reason why you would ever want to explicitly mark something non-constexpr, right?
Maybe some input-output functions, maybe.
Okay. Is that part of the paper? Like, is there a non-constexpr if it's going to be implicit constexpr?
That is constexpr false.
False, okay.
But it's not nice, but I think it should be easily changed to something else. There is also some same topic with constexpr explanation mark paper, currently known as const evaluate paper. So if this paper will be joined or not, I don't know.
That's, I saw that overlap with the constexpr exclamation point, because in this proposal, constexpr true says it must be done in a constexpr context.
It's the same.
Honestly, I like, it's more wordy to have to do this constexpr open paren true, but I feel like it's more consistent with the rest of the language personally, like it matches the no except and the conditionally explicit syntax.
I personally think that having true or false after constexpr will raise a lot of questions. People can ask, should I place expression here or not? So maybe it's not best idea to have true false. Maybe new keyword will be better. I'm not sure.
Maybe. But I do like this idea of this implicit constexpr. We are at the point now where we do have a few different tools that can tell us, oh, by the way, that function could be constexpr. Like, the compilers already know this because they know what operations you're performing inside it. And as your paper points out, they have to know that so that lambdas, because lambdas are implicitly constexpr.
Yeah, that's true.
I'd like to interrupt the discussion for just a moment to bring you a word from our sponsors. Authors of the PVS Studio Analyzer suggest downloading and trying the demo version of the product. Link to the distribution package is in the description of this podcast episode. You might not even be aware of the large number of errors and potential vulnerabilities that the PVS Studio Analyzer is able to detect. A good example is the detection of errors that are classed as CWE14 according to the Common Weakness Enumeration. Compiler removal of code to clear buffers. PVS Studio creators demonstrated the detection of such an error type, for example, in one of the latest articles, We Check the Android Source Code by PVS Studio, or Nothing is Perfect. Link to this article is also in the description of this episode. PVS Studio works in Windows, Linux, and macOS environments. The tool supports the analysis of C, C++, and C# code, and Java support is coming soon. Try it today. So since we're talking about the ISO committee right now, you mentioned that the intro of your talk, you live in the Czech Republic and that the Czech Republic is soon going to be a national body for WG21. Are you involved in that process?
I started the process.
You did? That's awesome.
Last year, Bryce and others told me Czech Republic is only O member, observing member. Do you want to be in committee? And I was like, yeah, but that sounds a lot of work. And I was thinking about it, and then I contact Czech bureau, which is responsible for communication with ISO, and they were quite happy. If Avast wants to give a lot of work into it, we are okay with it, and there will be Czech national body in form of our company Avast.
So, how long is this process, do you think?
A lot of work is about our lawyers. It's a lot of lawyery.
Oh, okay.
But, actually, it's just few signatures, and that's all. We are already O members, so the hard work is already done.
So when should this be official? Like, when should you be a voting national body?
I hope yesterday. I'm still waiting for lawyers.
Okay.
But soon. I will not be in San Diego, but I will be on next meeting.
Yeah, that's what I was going to ask, if you're going to San Diego. What is the next one after that?
It's in February, and it's on Hawaii.
Oh.
It's a good one to go to.
You're right.
Not that you'll be able to enjoy it, but...
I will be probably sitting in air-conditioned hotel room without windows.
Yes. That's what we've been told. At the beginning of your talk, you also mentioned you're involved with the C++ Prague meetup. How is the C++ community in Prague?
It's starting. It's small, and it will be bigger and bigger with each meetup, I think. There will be next meetup tomorrow, which is October 17. And there will be Tony van Aert. I was able to convince my company to invite some nice guests to talk here.
Your company recently had Matt Godbold out, is that correct?
Yeah, that's also my meetup.
Oh, okay. Very cool. I didn't realize that was the meetup also. My meetup has not flown anyone from overseas to come in. Although we have had people coincidentally visit from overseas because they were on their way to a conference here.
I wanted from the beginning that every talk to be streamed. It helps to spread the word about the meetup, and it's a lot about marketing of our company.
Right.
So you can watch the C++ Prague meetups online?
Yeah. Streamed live.
Awesome.
So who is your next speaker then?
Tony van Aert tomorrow.
Okay. Wow. That's a long flight for Tony. I'm curious, my experience in Eastern Europe so far is like Wrocław, Poland has a gigantic C++ community. It seems that Budapest does. Is it similar in Prague? Is there a lot of C++ development happening?
There is a lot of development. There is Skype, Microsoft, or Red Hat in Brno. And a lot of different companies. So they probably a lot of C++ developers, but they are hidden in plain sight, I think.
Right.
Well, you'll also be presenting your talk at C++ on C in early 2019. Are you planning on making any updates to it?
Yeah, there'll be a few significant ones.
Are you rewriting the library again?
Yeah.
I'm preparing few new tricks.
Okay.
To shock audience. Okay. And I hope there will be new engine in the library.
Wow.
Yeah.
So it sounds like you enjoy rewriting
nothing
it.
Promised.
Okay.
No, it's not rewriting. It's additional engine which can be used if there are no captures in the regular expression, only matching, which can be done much quicker.
Okay.
I had one more question about all these different iterations of the library. If you're, stuck on C++ 11 or 14, could you use one of the earlier iterations of the library, since the new one is kind of dependent on these C++ 17 and C++ 20 features?
I think the oldest one, I don't know if it's public, was on C++ 11 with the extension.
Okay.
But probably not. It would be a lot of work to make it work.
Yeah.
Okay.
I'm also curious, since you mentioned you had to build an LL1 parser first, is that parser component reusable? Is that something that other people could use to make their own parsers?
Yeah, you can just take part of my library. It's called CTLL, and provide new grammar, and you are good to go.
Okay. Oh, I see. Compile time LL. All right. Right.
Yeah. You can just design new grammar as form of table with function overloads, and you give me to grammar as a type, as one parameter in parser, and that's all. There is in my library there is a branch brainfuck, which is implementing language brainfuck with the parser.
That is
which I'd imagine is a very difficult language to parse.
It's actually very easy to parse.
Really? Okay.
Yeah, it's like 100 lines of grammar, which is nothing.
Yeah, my understanding is that language is one of those write-only languages. You don't.
Yeah, I use examples from Wikipedia. I didn't try to write my own.
Right. So one thing we haven't brought up at all yet is all of this compile time magic you're doing. Is talk about the impact on the compiler. How much does this affect the compile time of your project?
You mean just using my library, or?
Yeah, using your CTRE library, yeah. Like if I'm going to throw a half dozen regular expressions with your library in my project because I want really, really fast run times, is it going to take me an hour to compile my project?
No, it will take you only a few milliseconds per regex. On GCC, it's 200 milliseconds per regex.
For how big of a regex? Sorry.
I use medium-sized regex, I think 20 chars long.
Okay.
So it looks like most of ordinary regular expressions. In Clang, it's a little quicker, I think 150 milliseconds. Depends on your computer. But if you use same regular expression multiple times, compiler cache the parsing, so you're not paying anything more. So you can use your regular expression 100 times and you will not know it.
So that just, if I understand correctly, the compiler sees that you're instantiating the same template again and says, oh, I already know what's going to happen when I instantiate this template?
Exactly.
Okay.
If they are in same translation unit.
Right.
Okay.
So it sounds like you could, if for some reason these became a compile time concern to you, you could use them as extern templates, as Michael Case recommended when we had him on the show.
Yeah, probably. Or you can just wrap them in function in different translation unit.
Oh, yeah. That would make sense, because you just need to pass a string view or whatever to it that you want to match against. Okay. That's really cool. And, you know, Rob started out by saying this, but it is true. All of the comments on Reddit and Twitter and Slack seem to agree that your talk was the best one of the conference this year.
You got several applause lines. Like, people were pretty impressed from what I could tell in the video.
Yeah.
I was surprised at too.
Oh, and on that note, the first video that went up had to be pulled because it had an incorrect title. So it sounds like, Rob, you did find a video that stayed online.
No, there is no video currently online. It was pulled because there was wrong title. It was just regular expressions. That was missing compile time.
Right.
Oh, okay, so they haven't reposted it yet.
Yeah.
Oh, okay.
I'm
well,
still
hopefully
waiting.
they get it up soon.
Yeah. One more thing, since we're talking about the length of compile time for a regex, I think you did find there was an upper limit to how long a regex could be before the compiler would, be unable to process it.
Because the deep of template instantiation recursion is same as length of the string. You are limited by the limit of your compiler template instantiation recursion, so it's usually 100 chars.
Okay.
100 chars. Okay. I don't think many people are writing regex expressions that long, though.
Yeah, so it's not much usable for big JSONs, but for regex it's enough.
Yeah.
Yeah, and I think most compilers have compiler flags where you could extend that limit if you really wanted to.
Yeah. I actually was thinking about writing a paper which gives you ability to ask about limit of template instantiation recursion. So you can use it in your parser and give it a nice error message. Your regular expression is too long.
That would be interesting. Are you aware if the standard currently says if there's a minimum recursion limit?
I'm not sure, but there shouldn't be any.
Yeah.
It's just an implementation issue.
Yeah, that's probably true. I know there's some places where the standard has minimums, but wow. It's a very cool library.
Yeah.
Thank you.
Was there anything else you wanted to share with us before we let you go, Hannah?
I'm not sure. I don't know. Probably not.
Okay.
Okay, well, it's been great having you on. We'll get a new link to the YouTube video as soon as it's back up and put that in the show notes. And good luck at the Hawaii C++ meeting when you go there.
Thank you.
And I guess I'll see you in England in a few months.
Yeah, if anyone is on meeting C++, I will be there too.
Oh, right. I forgot that you had submitted to that one as well. Well, have fun. Will this be your first year meeting C++ then, you said?
Yeah.
It's a good conference.
I heard everything good about it.
Good.
Okay. Thank you, Hannah.
Thank you.
Thanks.
Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/cppcast. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode was provided by podcastthemes.com. At cppcast.com. Theme music for this episode was provided by podcastthemes.com.